matrix of our trained neuron. Our trained neuron, in this case, try to find this pattern on the first image. How? Because on our output we have different values. So then greater this value, then more similar image to our trained image. Is it understandable? Oh, again, a problem with the screen. Okay, I will check chat. You can message me on the email, I guess so. If you will have questions, you can message me to emails. This question about WhatsApp number. If you have problems with emailing me, please let me know in chat, and I will share the number. The next question is can't access to the screen. 𝗖𝘁𝘂𝗿𝗺𝗀𝗃. Sorry for my pronunciation again. I can be wrong. Please tell me if I'm wrong in this case. You can click twice on a shared screen and it will open on full screen. It should be open in Google Meet. Okay. So that means that our neuron here is a trained, it's already trained neuron. I'm not talking about training neuron yet. I'm talking about already finished training. I'm talking about neuron that already works as properly as we want to. So what I stop on telling you that this matrix try to find will give us a max value if this pattern will match to this matrix. So it means that in this case it's similar to the first one, but it's already below the max value. It's already lower. In this case, in the third case, actually we have the anti-diagonal line that actually doesn't belong to the first initial pattern that we observed here. So that's how neuron works. They try to find features, some specific patterns in a data. In this case, we are used images, well, quite simple images, low quality images, low pixel size, but still images or two-dimensional data. Same thing working as for text data or for digit data. So you should convert text to numbers and digits. I will not talk about this one much. If we will have time enough, I will briefly mention how does it work, but not on these sessions. Yep. So yeah, as I said, here we're trying to find some specific pattern. In each neural network, there is a lot of neurons. So usually these neurons aim to find, when the neural network already trained, these neurons trying to find specific features. For example, in a picture of elephant, one neuron will try to find the ears or trunk of elephant. Yeah. Or task, for example. Each of these neurons. So the neuron that trained to find tasks will not be triggered on ears, for example. So that's main principle of feature detection in the neurons. It's a extremely basic one thing, but you can imagine how it works. This is specific, extremely simple example. If we have several layers, I will talk about layers. If we have a lot of neurons for images, or we have extremely complex analysis of images, actually, it's not so simple to say that, oh, we will try to find the head of the elephant or ears of elephant or something like this. It's much more complex, and it's barely understandable for human being. So it's not so intuitively understandable, but it still works. So the neural network tried to find some specific features that in logic of this training can be possible for successful solution. Yeah. So I forgot to mention that neurons are separated in specific layers, logical connections, nodes for feature allocations. I will talk about this one here. So this is simple scheme of neural network. Usually, neural networks has input layer, hidden layer, and output layer. There can be a lot of hidden layers. Output layer usually is one. Input layer usually also one. So we process some input data and transfer it to hidden layer. Hidden layer usually changes a lot during the training, and output layer, and we will get some result on our output. Here in this example, we have 2 neurons as an input layer and 4 neurons as a hidden layer, and 1 neuron as an output layer. I will check 1 second for some questions. Okay, no questions. Going further. Okay, I see a raised hand. You can ask if you want to.
Hello. So I have a question. In a typical neural network, what is the rule of a hidden layer? I couldn't understand how it works.
Hidden layer? Oh, I will talk about this one a bit later,
Yes.
but yeah, a hidden layer here is usually the layer that not connected to initial input and not connected to final output. So this is a layer between these 2 layers. We definitely have 1 input and 1 output, and between these 2 layers, major layers, we can have a lot of hidden layers. The logic of works of these hidden layers is depends on the task where you train this neural network. For example, if you train this neural network to for object detection, it will try to find some feature of the object. Like for car detection, it will try to find some circle, some circles on the image, or try to find some doors of cars or similar objects. So this kind of thing. Did I answer to your question, or I can try to rephrase it in another way? Okay. So as I said before, right? So we have neurons, and each neuron has some inner function. Usually it's linear function. In this case, today we will cover only linear functions right now: activation function, and output and input. So we will go further for activation function of neurons. So this is a function that summarizes the results, the result of input processing for 1 neuron. We are talking right now about 1 neuron, not about layer. I mentioned the layer because it will be needed for further topics. So activation function summarize everything, and here we can see that there's most popular activation functions. It's not limited by this, though. You can use a lot of different activation function. You can use, actually try to write your own activation function. In this case, I would recommend to you to check the documentation for specific library that you are going to work with. If you're working with PyTorch, there's some specific logic to put activation function in a model or in a keras. It's a bit other logic, but it's still same activation function for all these libraries, for all these frameworks. The logic of activation function is the same. So you will have different results. So here's a plots of activation function. For example, 𝗼𝘁 is activation function that if our x, so input below 0, we will get 0 signal. If our x greater, x here is an input. If our input is greater than 0, then this function will return x, so the input value. Sigmoid function also quite popular one. There, I think to choose activation function is important when you. I will talk about this a bit later, but you should check what values does activation function can return. So in case of 𝗼𝘁, 𝗼𝘁 can return from 0 value up to infinity value. So it depends on your input. Sigmoid function will give you from 0 to 1. So sigmoid function usually can be used for probability. So if you want to predict some probability of object detection or not object detection of some data, you can use sigmoid. Leaky 𝗼𝘁 is similar to 𝗼𝘁, but not from 0. When specific value input in case of leaky 𝗼𝘁 is below 0, it multiplied by extremely small coefficient. So we will get, as a result of this function, negative value. Small, but negative value. Sometimes it can be useful. I will not talk about specific case right now. And there's hyperbolic tangents functions can be done, can be used from -1 to 1, and so on. So you can choose different activation function. This is not all types of activation function. This is most popular examples here. So now we understood activation functions, so that our neuron actually try to process some data, send it to other neuron through its own activation function. So it means that each layer or each neuron can have different activation function. So for example, this neuron input and this neuron will get 𝗼𝘁 function. Hidden layer neurons will get soft sigmoid function, and output also can have sigmoid function as activation function. So it doesn't mean that all layers of neural network should have same activation function. Now we understood how does our neuron works. Before we will go to how to train them. I will check our chat. Do we have some questions here? No. Okay. If someone still have screen sharing problems, let me know, please. Okay. So we going to backpropagation. Backpropagation is a principle when we can work with a lot of layers of neurons and change their weights depending on our error. So our error, the final error, is output minus real value. So what does it mean? As an output of neuron, we have some signal. But to train our neural network, we need to have a correct answers. We should compare it with correct one. If we don't know how to train neural network, so we don't know what we should see it as an output for specific input, we cannot train it. But if there is some specific case, like reinforcement learning, for example, but in these cases, during the training, the model itself try to find these correct answers still. So even reinforcement learning includes correct answers, set of correct answers for input. So we just calculate a loss or error here. And for many neurons, this formula. So yeah, as I said today at the beginning, so I put this information, detailed information, how does you can calculate how much you should change these weights here. You can see these weights, how much you should change them depending on your error. Using this formula, you can actually understand it. This case that I described here is not for one-dimensional case. It's not extremely case, so it's a general formula. So this formula can be used for many cases, except there is one suggestion that I used because the formula will be modified a bit depending on activation function. The activation function, the only one requirement I would say for now for you for activation function, that activation function should be should have derivatives on the whole set of values that you're going to use it. So it shouldn't have like gaps. It shouldn't have gaps. So there is some function that has gaps, and in this case you cannot use it for neural network training or as an activation function. So yep, there's some clarification about terms, about formulas, and so on. This is open source information. You can find partly it in books or in a Wikipedia, for example, and combine it. Yep. So I will go further straightforward to simple example of neural network model. It's extremely simple model that actually will try to predict a value depending on one input. Here, this is a correct math expression, but sometimes we cannot actually find math equation for specific values. For example, you can you find an equation to distinguish cats from dogs on the images classification issue, for example? It's hard to do. It's hard to do because photos will be different, images will be different, brightness of images will be different, and so on. So it's almost impossible. But in this case, in this example, we will get a set of data. Output of our data will be y value of this equation. So, sorry. Here we have input 1, 2, 3, 4, 5, from 1 to 10. List from 1 to 10. I converted to NumPy array because NumPy array is much more convenient to work with when you work with neural network, or also possible to use TensorFlow tensors. Also one of the possible, but usually TensorFlow tensors used with the TensorFlow framework. And the answer to correct answer for our data will be the following. So for 1, when x equals 1, we multiply x by 2 plus 1, we will get 3, right? When x equals 2, we will get 5. When x equals 3, we will get 7, and so on. Yep. Okay, now we should initialize the weights of our model. In our case, we will get only one neuron. Only one neuron. So in this case, we will need to predict this value and this value. So technically, sorry, we will get, we will try to understand what W and B values are, because X we already know it is our input. We already determined this, it is an input. So initialization of these both values is a random. It's a random right now. I put here the random seed because sometimes, well, the random seed used for reproducibility. Sorry. So if we will run again, we will get the same random values. But if you will remove this row, nothing really changed. You will, when you run this cell, you will get different W and B each case. That's all. Learning rate. Learning rate determines how much we can change weights. So if our learning rate is extremely big, it can cause some problems. And epochs, how much times we will train our model. So, and losses is a list to actually have like record of our errors or our loss. Do we have some questions? Not now, right? So now we trying to run 100 epochs, so just a cycle, and we tried to predict. So we used this random value, we used input value, and we used another random value, and we get some prediction. Of course, initially this prediction will be wrong. We will get some loss. This loss, in this case, I calculated the loss as a mean square error, but it's also, I'm sorry, it also can be absolute error or other types of error. So there's a lot of types of losses. There is a lot of approach to loss calculation. So here we took the mean value of error for all array, because this is array. It means that as a prediction we will get also array, and we will calculate the mean value of this array, and we will just put it in our list. The following steps, actually the calculation of gradients. So how much we should change the weights. We calculate the whole losses together for each element of array. Here we summarize them. Here multiply by x train. This is input, our input values, and this is a gradient, give us a gradient of w. So I call it dw because it's the derivative of w, derivative of our w weight. And bias. So the second, usually when you use these linear equations, I'm sorry. Now, when you use these linear equations in models, you will get this b determined as a bias. So when you will work with the frameworks, usually it's called bias. So now we can calculate biased gradient. It can be done the following way. This multiplier here actually can be different. So in this case, this multiplier just for example. It is just for our example. It doesn't mean that we will get this always for our case. And now, when we clarified how much we should change our weights and our bias, we should change our weights and our bias. And learning rate here, as a simple example, in this simple example, is just a coefficient that, since it has some low value, it just reduces changing of this weight. So if you will get high learning rate, it doesn't mean that your model will train fast. You should be careful with this. And for each of our epoch, we will get loss, number of epochs, and so on. And we will plot the loss graph. I will change right now here random seed to 50, and we will run it. So as you can see, initial value of W is 1.29, and for B is 0.38. And since our loss was quite high here, on the next after 10 epochs, you can see that our W and B already significantly changed. W changed quite fast. You can see that 2 is already almost correct number. It's almost close to 2. So it's not superlative, it's 2.0698, but it's already close to 2. But our bias not close to 1. It's only 0.51. But since we are going further, we trained our model further, our W is changed closer to 2 value, and B is changed closer to 1 value. Not extremely close in this case, but quite close, as you can see. And here is our plot. You can see that we had loss significant at the beginning, and then it drops and goes down. Okay. Yep. But this is a case of one weight, one neuron and one weight. What should we do if we have a lot of neurons or a lot of weights for one neuron, a lot of data, input data? Actually, it's the mechanism and logic is the same. You do the same procedure, but in case of many neurons or many weights, you will get here not a list but the matrix. That's all. Sorry. Here's an example of gradient descent. Gradient descent is the thing that we calculated here. I used Keras model, as I said. Here. I will not explain the things here yet. I will just get some data. I generated some X and Y data. Not actually very good example. I need to regenerate it. Sorry. Well, I don't like it. It's not the same thing. So we will get here a two-dimensional array as a weights, because we will have here one neuron, but with two inputs. So for example, here, the red dot represents the current weight position. The vertical line represents a loss. So the greater it, then greater loss we'll get. And here, this surface represents actually how much our loss will change when we change the weights. Not a great example, for example. So yeah, you can see that our train was started from specific error, then it goes up and then goes down. So it's not best actually way to not most efficient way of training, but we will get this result. And in three-dimensional plot, visualization is not very good here in this example. Yep, you can see it doesn't follow. I expected that actually this weights in this example should moves along the surface. So never mind. So here another picture. Zoom it in. In this picture, for example, there's W1, W2, cost or loss can be done, and we have the space of possible solutions. So for each combination of W1, W2, we will get specific loss. So our aim to find a minimum value of loss. So we don't know what weights should be. We should adjust it during the training. The same as we done here. You see? we adjusted it, we change our weights, and then we calculate again loss. So this procedure leads us to some specific minimum value. But here in this example, you can see that actually the minimum can be not in one place. It can be local minimum or global minimum in different dots. Here, only 2 weights. You can imagine that if we have n weights, we will get n-dimensional plot. So usually for visualization, only 2-dimensional plot, 3-dimensional plot used, because with higher dimension we cannot work, right? So we are human being, we don't see besides of 3 dimensions. I will start from the linear or so-called dense layer. It's the first layer that we will study today. Oh, not today, it's in general. For best performance, you can change CPU here to GPU, for example. Change run type. You can use T for GPU or something like this. I already put T for GPU. It will increase speed of training of neural model, but it also has some limits. So if you're going to use for big projects, I wouldn't recommend it to you. Big projects for collab has limitation. You will Google will interrupt this using of GPU like in 4 hours or 3 hours. So if your model will able to train and save the weights in 3 hours or less, it may be possible to use Google Colab, but for bigger project, it's not. Anyway, actually, you also can check how to use Google Colab with local resources of machine. You can use Google GPUs, but also you can use your own GPUs using the Google Colab. It's also possible. I'm sorry. Should remove this thing. Okay. First thing, we need to install TensorFlow and Keras. And the first task that we are going to solve today, not today, but the first task for neural networks will be classification of digits, the handwritten digits. I will show it to you. This is a script for loading the data. This is X. This is input. Y is the output. So X is a NumPy arrays, and the shape of X 28 by 28, and 60,000 examples of these handwritten digits. Here you can see this is, for example, digit 3. You can see it easily by your eye, right? But for computer script, it's not extremely easy. So we took tense image, show it, and then took tense label. So these correct answers usually also called label. So this correct answer for our neural network we can call label. And our label is 3. We can see it. We can change it. For example, let's put 15. It's a number 7. Sometimes it's actually even visually this numbers is digits. It's hard to determine actually. For me, it's closer to 1 than for 7, right? But the person who wrote it expected to it be to 7. So the shape of our each of our image here, 28 by 28 pixels, quite small, right? But even for this case, we should keep in mind that this value is not extremely easy to work with. So with this model can be done on CPU that I'm going to show you. But if you are going to work with a bigger resolution of images, you will need much more GPUs. Moreover, for bigger project, like for generative models or something like this, to train them, they also require a lot of GPUs, and they apply specific technique to split data training in several chunks. But I will not cover it. It's quite specific topic. Yep. So the shape shape will give us a number of images. We have 60,000. -1 here, reshape, means that we are going to flat our image. We going to convert our image into array. Since if we have, for example, this here is an example, if we have image 30 pixels by 30 pixels with three color channels, we will get 2,700 elements of array. Yep. And here, if we have 28 by 28, as we can see, we don't have here color channels because it's grayscale image. We don't have color channels here. We just have multiplication. We have 784 value. We also can calculate the values of each pixel. For example, we took the random image and we calculated here what minimum value and what maximum value of image for each pixel. So max value of pixel. So here max value of pixel is 0. Mean value of pixel is 0, and max value is 255. But to work with the neural networks, you can actually work with these numbers, but it's better to have normalized data. It's better to have data from 0 to 1, because it will increase in many cases, not in all cases, but in many cases it will increase performance. There is a lot of normalization process. In here we will use extremely simple one. Just divide by 255. So we just limit our max value by 1. So our maximum value will be 1 here. And how we should, in our model, we should also think how we should interpret answers of our model. For this case, I'm going to show you one-hot encoding, so-called one-hot encoding approach. We can try to build only one output that will give us exact number from 0 to 9, but this will be not so effective. Much more, the training of this model will be really hard. So you will get a lot of mistakes. You will get a higher value of loss. What to do? So one-hot encoding will help us. One-hot encoding, it means that we will do the following steps. We will get 9 answers. The array that length is 9, or technically 10, sorry. But each element of array will be responsible for a specific value of number, predicted number. So if we will get 0, if image is supposed to be 0, we will try to find max value here in the first element of array. Second element of array will be responsible for detection of 1. The third element of array, detection of 2, and so on. So in here, in this case, we can see that if our chance here 1 value, this highest probability to find digit 9 on image that we got. So this one-hot encoding is quite spread in neural network development. So quite useful method. You can read about it here and read about it in the Hugging Face, for example, or other resources. I will not focus on this right now. So our case right now, we have 10 classes. 10 classes, it means that 0, 1, and so on, up to 9. Together, the total number of our class, of our digits, is 10. Each digit, I call each digit as a class. is a class. So first of all, we need to try to do our manual one-hot encoding conversion. I will show it to you. So I took X-train shape. I took class amount and I created 0 arrays. The array that only contain only zeros. And for each element of our correct answers, I put value. So here, specific value in specific element. So, for example, here I get like this is a number of image, no, a number of label, and this is a value of name label. So here correct number is 3, right? So we took for example this tens, right? Tens element. We took tens element, and on the third element of our array we put 1. Okay, we'll not focus on this much. This is import of model. Okay, I'm running out of time. Sorry. I will check the questions. Okay, meeting services mounted. Okay. This many sessions is there recorded sessions about recorded sessions. I guess Dr. 𝗤𝘁𝗵𝗁𝗶𝗶𝗁 can clarify it. As far as I get, as this recordings are already shared with many students, so you can cover up. Yeah. Recorded sessions. The question from FemsTech. Can we train neural networks without GPUs? Yes, you can, but when you do a big model, it will be extremely slow. So extremely slow, because you have in GPU you will get a lot of operations, simple operations, but quite frequently, a lot of simple operations in parallel. But in CPU, you will get, you can perform complex operation. But if you will try to load your CPU by simple operations, it will not boost speed enough. So it's better to have GPUs, but still for specific task, for example, not bigger models or something like this, you can do it on a CPU. For example, so in our case that we are going to use here and on these sessions, you can do it on a CPU. So okay, so linear layer that I told about in the beginning of section, linear or dense layer, is a layer that actually the function of this layer will be looks like this formula. So B is a bias, K is our value of weight, and so on. Dense linear layer in keras, in library keras, is called dense layer. You can see it here. There is documentation. I will import it from layers, and the sequential. I remind you that I imported sequential model. First of all, it's creation of model. Then we can do the method add, and we can add dense layer here. As you can see here, I used 784. Can somebody say to me why I used this number? I will do it like here. Why I use 784? Is it better? Any suggestions? Even wrong one suggestions. Why I used 784? Do you remember what we are going to classify? What images? Images of what? We loaded images, some images. Somebody. No? Okay. So this 784, because you remember that when we worked with these images, when we flattened it down, when we flattened out images, we got this number. And since we got this array, this is array that will be our input. So our input dimension here is 784. Activation function I used here as a ReLU. I used bias, so the equation will include B. If I will not use bias, my equation for this linear layer will be this one. But since I used bias, it looks like this. 900 neurons in the first layer. The second layer is 400 neurons, also activation ReLU. This is another layer, and the last layer with 10 output neurons and activation function softmax, because we are going to predict probability of digit detection. We are going to use softmax because softmax function, I can remind you this one. Not here, for example, but softmax function is quite close to sigmoid. It from 0 to 1 also. Softmax function, and also softmax function will allow us to do several attempts of prediction. So if our, for example, if our label expect to be, sorry, I will rephrase it another way. For example, if we not sure that is our answer is wrong or correct, yeah, no, also not the best idea. 1 second. Let me rephrase. Softmax allow us to do not only for one value in this array, in this one hot encoding vector, but for several. So we try to maximize only one value here using softmax function, but it also includes that we will get, for example, here, for example, will be 0.8 and here 0.2. So in total it will be 1, but the probabilities are spread along the array. In this case, our activation function could, softmax activation function could help us to build it. Here's our, oh, so big. Here's our scheme of model, as you can see. I have a question to you. Based on, based on this 3 rows, can somebody try to say to me how many neurons do we have in input layer? Just for your just to remind to you, we have 3 types of layers: input layer, hidden layer, and output layer. So here, can somebody say to me where here how many neurons do we have in input layer? Any ideas? Just a number, just throw it. It shouldn't be correct number. Yeah, you can you can tell.
So according to that example, 1 neuron per input feature. We need 1 neuron for per input.
Yeah, but here is a specific number that I put how many neurons I have here in input layer, in specific input layer.
We should calculate the index from 0.
No. You are talking about when we are trying to fit amount of neurons, so optimize our neural network. But it's a different topic. That's nice that you talk about this one. It's also an interesting topic to optimize your neural network, because sometimes you can build your model and you can put too much neurons, and these too much neurons will take a longer time to learn, to train them, and so on. But for specific tasks, you can use much lower value of neurons. So thank you for your attempt. In this case, we have 900 neurons specifically in this case, and inputs, as I said, we have 784 inputs. This layer, the second layer, as you can see, contain 400 neurons. How does this layer can be called? Before we talk about input layer, right? How the second layer can be called? How we can split layers in general in all neural networks? What 3 types of layers neural networks has? No one? Okay. Okay. I will go back then for a second. I want to remind you that we have 3 types of layers: input layer, hidden layer, and output layer. So here, the second layer is our hidden layer, because this is an input layer, and this is our output layer. Hence, since we already got input layer and output layer, the middle layer between these two will be hidden layer. Okay. Going further, the loss function can be, you can read about different loss functions, and optimizers too. You can check what optimizers do, because optimizers actually, where it is, for gradient descent, for example, optimizers can help to not put your solution to local minimum. Optimizers can, for example, hold a pulse. So if your weights are changed recently quite much, as in the physics, if you pushed the ring from the mountain, it will gain some speed. But if it will go, when it goes down, it gains some speed. But when it goes up, it lost some speed. But since it already gained some speed, it will not stop immediately, right? So this approach also used in some neural networks. I will not focus on this. It's just fun fact that some physics principles are used for coding. This we are done. And to check that our models are okay, we should compile a model. We can show a summary of model. It will show us how much parameters do we have and how much memory do we need just to store these parameters. It's an important thing. And the fit method of model class will allow us to start training of our model. So what should we do? We have done. We built our model, right? We compile our model, and now metrics accuracy is how close to our target is the answer. It's not a loss, it's opposite of loss, just in case. Accuracy is the opposite of loss, and it varies from 0 to 1. Yeah, loss can be greater than 1, or sometimes below 0 if it's mean absolute error, for example, and so on. So the first argument here is an input data. The second argument here is a label or output data. Third argument is a batch size. What does it mean? It means that for loss calculation at one cycle, we should take 256 elements of array. I mean, we took this value of images for one set of loss calculation. If we will calculate error for each image, it wouldn't be so effective because we don't need model that will detect only one image. We need model that will detect different images, right? So the batch size is important thing. But also, if you will not have enough RAM, for example, or random access memory, you can reduce it, and it will give you the opportunity to train your model easier. Epochs, it is how much times we should go through the whole batch of our data. So for all 60,000 images, how much times we will cover it? We will try to cover it 20 times, for example. And verbose is just visualization of training process. Let's go. Our training. First of all, as you can see, right? So this shows us loss, accuracy, and so on. So our accuracy right now, 99.6%. Let's check it. We got specific random image at index 400, or like, for example, let's do it 540. We got some results. We used method of model predict. We use specific sample. Since we have this as an input, we should also modify our input data because yeah, we need to have 1 by 784 value, which we cannot put just a set of numbers here. We put it here, model answer here. We can see this is softmax activation function, what does for us. And we can see that this is for first index. We have low value, low value, low value, and only third index or fourth index gives us almost 1. This index corresponds to number 4, right? Oh, number 3, sorry. To digit number 3. So we expect to see here digit number 3. But our answer, not in the form of digit right now, it's in the form of this. We see it, right? It's not easy to interpret it by human eye. So we just choose index of max value using function, built-in function in NumPy, argmax, and we can see. So model answer is a 3, and true label is a 2. Our model made a mistake, for example, in this case. But you can see this is quite controversial, controversially written digit. So we can change it to this one, for example. Sorry, I forgot to do it here. Yeah, I forgot to change it here. That's why maybe our model made a mistake. Yeah, here our model and the label are matched together, so we got the same answer. Yeah, I have a bit more information here. I will not cover it too much. I will cover it on the next session. Sorry for delay. Thank you for coming here today, and I will send to you assignments soon. So just to summarize everything, today we covered what is neural networks, how do they work, what is a neurons, how do they work, what is a backpropagation, a bit, what is activation functions, the most popular one hot encoding in keras, the dense layer, how to use it, dataset manipulation. We changed the shape of our input data, we flattened it, and also we normalized data. You saw how can be done neural network development in keras. It's quite simple models. So when I will send the assignment, I also will send a link to this laptop, notebook, sorry, to this notebook. And in this notebook, you also can, if you will struggling with your assignments, you can check it here. There actually all answers to homework actually is here. All information that you need for homework is here for this assignment. Yeah. So you don't need much, but you also it's good to go to read the documentation for this keras framework or TensorFlow if some of you will be brave enough to work with it. But I wouldn't recommend the keras is the best for start. For start, it is one of the most comfortable frameworks to work with. Yep. And that's all for today. Next session we will cover 1 second. I will not talk about additional example. Here I will talk about the training validation data set, how we should split our data to be sure that our neural network will not be hallucinating when it comes to real data, that the neural network didn't saw it yet. And also what? Yeah, so we will talk about overtraining problem, how to detect the overtraining of a neural model, overfitting or overtraining, never mind. We will talk about the solutions, dropout, batch normalizations, and combination of these two methods. I will try to cover it fast, but yeah, we will talk about this. And also for next session, there will be object detection. I will talk about YOLO model. It's quite complex model already. We will jump quite fast, but it's quite ready to use model. So it's almost easy it's quite easy to start to work with this model. Yeah. That's all for now. Thank you for coming here today and for listening to me. Thank you for asking questions. I hope that next time you will get more questions. Have a nice evening or day. We have already evening. Yeah. And have a great weekend. Thank you.